Before we ever get to addition and subtraction, and long before we tackle fractions and decimals, there's so much understanding that needs to take place. So here I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one-to-one is called subitizing. Some say sub, some say su. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these two hands, for example. If we were to put some candy in each hand, and then we were to ask a student, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count. So when students come to us in kindergarten, we now know that they have this idea of subitizing and more or less that they've been working on. So from there, we introduce rote counting. Rote counting, well, it's kind of like this. As students are learning the alphabet, they might say LMNOP and have no idea that there's actually letters embedded in there. Rote counting, same thing. Students are just working on that count sequence, the reciting of names. So an example of that would be as if we asked a student to count from 1 to 6. They might say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said stop at 6. But you know what? They can't. They have no idea where 6 is in that count sequence. Well, in kindergarten, students should be working on that count sequence from 0 to 100, forwards and backwards. I think most students in kindergarten have had exposure to a hundreds chart or a 99 chart. But what about this one on the right? When the value increases, the numbers on the chart rise up. Now when we count up from 0, we don't go down, we actually go up. That might make more sense to kids. Something to think about. So as students are working on this idea of rote counting, we begin to introduce this idea of one-to-one correspondence. And to be honest, one-to-one correspondence, it's much more than simply tagging numbers to objects. Here's an example. If we ask a student to count 8 and place them in the bowl from a set, and they're able to do that, they're a producer of counting. They're able to do that one-to-one tagging to 8. Now, if you ask them how many were in the bowl, they don't know. They'd have to go back and recount them all over. A student that we'd ask how many didn't make it inside the bowl, well, they're a counter. They can count a finite set of a quantity. So for instance, there was 4 that couldn't make it. So we want to make sure that students are both counters and producers. And one way we can do that is by building this understanding of tagging, but not always with numbers. So here we have 6 bears, and we want to match each bear to a green present. This idea that's happening in one-to-one correspondence, it's really, really big, and we need to make sure that we devote enough time for our students to develop this understanding. So as students are working on rote counting and one-to-one correspondence, cardinality gradually makes its way into the conversation. What cardinality is when students are counting out a set of objects. The last number in that count sequence describes the quantity in the set. Students might count this pattern here of these pennies, but they might double count some. So now they use a counting strategy where they line them up and count from 1 to 8, and they know that they said 8 last, so that there's 8 in the count sequence. This was an example of a counter with the pennies. And on the bottom here with the rec and rec, we have a producer of 8. And they're able to tell you that it's 8 because of the last number. We then move on to hierarchical inclusion. Yeah, it's a really big word. But all that it means is that students understand that numbers are nested inside other numbers. So if we take that penny, for example, students would know that if you had 8 pennies, you must have 7 pennies. That numbers are nested inside the numbers. So if we ask students to put 7 inside this circle, do they need to count out 7 pennies, or do they just remove 1 and drag the set into the circle? The same idea with the rec and rec. Do students count out 7, or do they just know to remove 1 because 7 is nested within the 8? And at the final part of this progression of early numbering counting comes number conservation. The big idea here is that students understand that there's a decomposition of number. We might ask, are they the same? Students would say, yeah, we have the same number. But if we stretch out the blue row and ask which one has more, students might say the blue. This is at the heart of number conservation. It's about decomposition, that numbers can be broken apart, and that numbers, the whole, is made up from parts. So at the beginning, we talked about a perceptual subitizer. Well, here we have 3 sets of 4. Well, when students get to this piece in the number sense trajectory, they understand that 4 is made up from parts. So now when we show students these dots and we show them these yellow cards, they're able to see that 4 just isn't a name, it describes the parts of a whole. Now we're getting to that conceptual subitizing. There's a whole lot happening here. One thing to remember, the turtle won the race. Thanks for watching.
Let's continue the conversation on Twitter.